This is OPI Structure Part 6, PowerQuery. When we have project data, for PowerOpI in my case, in Excel structured tables, we can use PowerQuery instead of using Excel data connections we used earlier for a similar result. Make sure to save each workbook containing the tables. The next step is to connect to the Excel structured tables using PowerQuery. For Path 2, which is Excel tables into PowerQuery, start by clicking down this sequence: Excel ribbon Data, Get and Transform Data section, Get Data, From File, From Workbook, and navigate to the workbook. PowerQuery shows the Navigator pane listing the tables available and sample data in each. Select a table to connect and pull down on the Load button and select Load to just create a connection. You connect directly to the structured tables, probably named like TBL table name. You don't need the VBA code snippet that would create RNG table name. PowerQuery can see the Excel structured tables. We don't need to copy the table, just provide a connection to the existing table. So in the Import Data pane that pops up, select Only Create a Connection. PowerQuery shows the table just connected in Excel pane's Queries and Connections. Now repeat this sequence for each table to connect. Start with the Excel Data ribbon, Get and Transform Data, section Get Data. We'll ignore this for now. For Path 5, which is Excel tables first into a SQL database and SQL queries, and then into PowerQuery, you would click down the sequence Excel ribbon Data, Get and Transform Data section, Get Data, From Database, From Microsoft Access Database, or from SQL Server Database, etc. Now, using Path 2 to query the connected tables or external queries through PowerQuery. We're going to build the same query structure that we showed earlier in the query block diagram, and using a single query connecting multiple tables instead of stacking several queries. To build a query in PowerQuery, start with ribbon Data, Get Data, Combine Queries, Merge. The Merge pane pops up. Select the left table and right table for the query. For example, in the first PowerOpI query, left is table alloc and right is table BOM. Select the field to join on in each table. In the first PowerOpI query, in left it's alloc rev key and in right it's BOM item key in. Make sure the field join kind is left outer. On OK, the PowerQuery editor window pops up. You can choose columns, but all columns is the default, and that's what you want. The right table will be shown collapsed at the right of the pane, table BOM in my example. Click the expand icon in the column title listing that table. Name the query in the Properties Name field in the Query Properties pane at the far right of the PowerQuery editor pane. Now we join the rest of the tables into query. In the PowerQuery Editor Home ribbon, use the New Source button at the right end to add another table to the query. Then use the same steps as before to select the Join fields and join type. Remember to expand each added table to the PowerQuery Editor pane. When all tables have been added and linked, remember to create the aggregation fields the query must create for allocated subassembly, aggregated quantity, and aggregated cost. That's shown on the slide we'll cover next. Follow that description, then return to this description and complete building the query. Pull down the PowerQuery Editor Close and Load button and select Close and Load to. In the Import Data pop-up, select Only Create Connection and click OK. That creates the query, which will now show in the Queries and Connections pane in the workbook. On the next slide, we'll use the query connection we just created to drive a pivot table. In the query just constructed on the previous slide, there was a step to create aggregation fields if they're needed. Usually that's when using a BOM table to explode elements in table alloc. First, let's cover how to build those aggregation fields. In the query editor, add Column tab, General section, Custom Column button. In the Custom Column pop-up pane, name the column something like alloc sub quantity. Select from available columns to create equals quantity times tablebomb.subquantity, field names in brackets, and click OK. Remember to set the Query Editor Home tab, data type, to whole number or an appropriate numerical type. Again, select Query Editor, Add Column tab, General section, Custom Column button again. In the Custom Column pop-up pane, name this column something like alloc subcost. Select from available columns to create equals quantity times tablebomb.xcost, field names in brackets, and click OK. Remember to set the Query Editor Home tab data type to whole number or an appropriate numerical type. When the aggregation fields are complete, go back to the query build procedure on the preceding page. So back on the previous slide to finish building the query. When that query is completed and loaded to a connection, you can use that connection to drive a pivot table. In Ribbon Data, Queries and Connections, in the Queries and Connections pane, right-click the query, select Load To, and select Pivot Table or Chart. Excel presents the Pivot Table Editor. Now you can build the pivot table. Some assessment of differences between using an Excel data connection or PowerQuery. First difference, connecting Access using a data connection, only a single refresh is needed to update pivot tables with updated data in the Excel structured tables. PowerQuery requires multiple refreshes. If you have multiple stacked queries, you need to repeat the refresh until pivot results are stable. You can limit this by building two-level queries, as we did in the example, one level to connect to the tables and one level to link all the tables in a single query. Next difference is about adding or deleting columns in the Excel structured tables. We use select star in Access SQL so that field changes will cleanly flow through to the end result pivots on refresh of the pivots. Using PowerQuery, flow through does not appear to be automatic. I think this is a property of its underlying SQL Server Analysis Services engine, but not sure. It may become better understood or even fixed later. To fix this, view the Queries and Connections panel in Excel via Ribbon Data, Queries and Connections. Then for each query that any updated Excel table flows through, right-click the query and select Edit. In the PowerQuery Editor, in the Applied Steps pane at right-click each expanded table name, for example, an entry called Expanded TBL BOM, then Edit Settings, then Enable or Disable Changed Fields. A two-level query structure limits the amount of work required. Very inconvenient for PowerOpI, which has field changes frequently, but okay for analysis of static data though. Adding calculated columns within a query in Access, such as an aggregated quantity field, works straightforwardly. But in PowerQuery, the default data type is text, so pivot totals don't work without some help changing the data type. We did this in the example. In PowerQuery Editor, on tab Home or Transform, select Data Type and set a decimal number, whole number, currency, duration, and so forth. Some date format silliness in Excel. First, you have more control of date calculations in Excel than in SQL, so do as much as you can in Excel before going into a join. Then when data reaches an Excel pivot table, if a field type is a date, then if there are any blanks in the data fed to that field, the entire column will format as date values, meaning the numbers, overriding any format changes you attempt to set. You can work around this by creating and using a formatted text field from the date data field and feeding that to the pivot. If you do a join from within Power BI from tables that have been put into the data model, explosion of layered tree-structured data, such as joining allocation and BOM tables, is seen by Power BI as a many-to-many relationship and is not supported. It is disallowed and reported as an error with no valid result. They intend for you to use a bridge table, but that imposes a complex structure into Power BI that's unreasonable to expect a program manager to continually manage and update. The difference between static data analysis versus dynamic operational data. PowerQuery does support this structure if it's called from Excel, as we did in the example. So you could do joins of this type from Excel through PowerQuery, then either reporting the query result from Excel or feeding the query result into the Power BI data model and reporting from there. An alternate workaround, do the query join from Excel through Access or SQL Server, then feed the query result back and report in Excel, else through the Power BI data model. Power BI Desktop doesn't support pivot table reporting, so you have to do that reporting from Excel or via the Excel Power BI Power Pivot. Excel supports most, if not all, the graphical reports that Power BI Desktop supports. This OPI structure sequence continues in OPI structure part 7, import.